Hello everyone, and welcome back to the channel. Today, we retaking a journey to a celestial body that has been humanity's neighbor for eons. Our one and only natural satellite, the Moon. It's that familiar silvery orb in the night sky. But how much do we really know about it? Let's dive in and uncover some of its most fascinating secrets. First things first, how did the Moon even get here? The leading theory is pretty dramatic. It's called the Giant Timpact Hypothesis. The idea is that about 4.5 billion years ago, a Mars-sized object, which scientists have nicknamed Theia, slammed into a very young Earth. This colossal collision sent a massive cloud of vaporized rock and debris into orbit around our planet. Over time, gravity pulled this material together and it coalesced to form the Moon. So, in a way, the Moon is a piece of ancient Earth, forever bound to us by a shared, violent past. It's pretty mind-blowing to think about, right? Now, when you look up at the Moon, you notice it has dark and light patches. These aren't just random splotches. The dark areas are called Maria, which is Latin for seas. Early astronomers mistakenly thought they were vast oceans. In reality, they are huge, flat plains of solidified basaltic lava. Billions of years ago, massive asteroid impacts cracked the Moon's crust, allowing magma from its interior to well up and flood these enormous craters. The lighter areas, called the highlands, are the older, more heavily cratered parts of the lunar surface. They're made of a lighter-colored rock called anorthosite. So when you see the man in the Moon, you're actually looking at the contrast between these ancient lava seas and the rugged highlands. Let's talk about the Moon's dance with the Earth. You've probably noticed that we always see the same face of the Moon. This isn't a coincidence. It's a phenomenon called tidal locking or synchronous rotation. Over billions of years, Earth's gravity has slowed the Moon's rotation down so much that it now takes the exact same amount of time for the Moon to spin once on its axis, as it does to complete one orbit around the Earth, about 27.3 days. This perfect synchronization means one side is perpetually facing us. This has led to the mysterious dark side of the Moon. But that's a bit of a misnomer. It's not permanently dark. It gets just as much sunlight as the side we see. A more accurate name is the far side of the Moon, a landscape that remained completely unseen by human eyes until the Soviet Luna 3 probe photographed it in 1959. The Moon's influence on Earth is profound. The most obvious effect is the tides. The Moon's gravitational pull creates a bulge in Earth's oceans on the side closest to it, and another bulge on the side farthest away. As the Earth rotates, these bulges move across the planet, causing the rhythmic rise and fall of sea levels we call high and low tides. The Sun also has a tidal effect, but because it's so much farther away, the Moon's pull is more than twice as strong. So, next time you're at the beach, you can thank the Moon for the waves lapping at the shore. But that's not all. The Moon also helps to stabilize Earth's axial tilt. Our planet is tilted at about 23.5 degrees, which gives us our seasons. Without the moon's steadying gravitational hand, this tilt could wobble dramatically over long periods, leading to extreme climate shifts that would make life as we know it very difficult, if not impossible. In a very real sense, the moon acts as our planet's anchor. Let's shrink down and imagine walking on the lunar surface. The first thing you'd notice is the gravity or lack thereof. The moon's gravity is only about 1/6 of Earth's. That means if you weigh 180 pounds on Earth, you'd weigh just 30 pounds on the moon. This is why the Apollo astronauts could take those giant, bouncing leaps across the surface. It would be an incredible feeling. But it's not all fun and games. The moon has virtually no atmosphere. This means there's no air to breathe, no wind to blow, and nothing to scatter sunlight or hold in heat. The sky would be pitch black even during the day. And the temperature swings are extreme. From a scorching 127 degrees Celsius in the sunlight to a bone-chilling -173 degrees Celsius in the shadows. Without a specialized spacesuit, you wouldn't last a second. The lack of atmosphere also means there's no protection from micrometeoroids and solar radiation, making it a very harsh environment. Even though it's barren, the moon isn't completely inactive. We now know there are moonquakes. These are tremors, similar to earthquakes, but they have different causes. Some are caused by the cooling and contracting of the moon's interior, while others are triggered by the gravitational pull of the Earth. There are also shallow quakes caused by meteorite impacts. These moonquakes are generally weaker than major earthquakes on our planet, but they can last for a much longer time because the Moon's crust is much more rigid and dry than Earth's, allowing seismic waves to ring through it like a bell. And what about the future? The moon is once again a hot destination. NASA's Artemis program aims to land the first woman and the next man on the moon, with the goal of establishing a sustainable human presence there. Why go back? The moon is a scientific treasure trove. It's a perfectly preserved record of the early solar system. By studying its rocks and craters, we can learn more about how Earth and other planets formed. It's also a potential stepping stone for missions to Mars and beyond. We could learn to live and work on another world, test new technologies, and even use lunar resources, like water ice that's been discovered in permanently shadowed craters at the poles. This ice could be used for drinking water, breathable air, and even rocket fuel. The moon could become a crucial outpost for the future of space exploration. Thinking about this cosmic relationship is truly humbling. The moon has been our constant companion, shaping our planet, our culture, and our dreams for as long as we've been looking up. From ancient myths and legends to the scientific breakthroughs of the space age, the moon continues to captivate and inspire us. It's a reminder of the vast, incredible universe we are a part of and a beacon for our future adventures among the stars. It's not just a rock in the sky, it's a part of our story. Thanks so much for joining me on this lunar adventure today. If you enjoyed this journey, be sure to hit that like button and subscribe for more explorations of our amazing cosmos. I'll see you in the next video.